Now, in order to reach airport, the family starts from their house to the airport. They book a prepaid taxi, but they don't know what's the distance between home and the airport. The taxi charges rupees 5 per kilometer. Now, in order to calculate the distance, let us assume the point, that starting point, that is their home, as the origin, that is 0 comma 0. And now let us take the coordinates of the airport as, let's say, some 36 comma 15. Now we have two coordinates. Now we have to find the distance between these two coordinates. Now, in order to calculate the distance between their house and the airport, we have the distance formula, which is whole the under root of x1 minus x2 the whole square plus y1 minus y2 the whole square. Now we have the two coordinates, that is, we have the value of x1, this is x1, this is y1, and this is x2, and this is y2. Now, upon substituting these two values, we get under root 1521, which is root 39. Now, since the total distance between their house to the airport is 39 kilometers, the taxi charges rupees 5 per kilometer. So, we are multiplying rupees 5 into 39 kilometers, which gives us rupees 195. So, the person has to pay 195 before he starts the cab journey. This is the check-in counter of the airport. Now, the CEO of the company has asked their airline executives to keep the board for their airlines. We have two different people here. These two belong to different airlines. This lady belongs to airline A and this lady belongs to airline B. So, the staff of airline A wanted to keep their poster of their airlines. But where do they keep? Let us see how we can help them. Here, let us say we have the coordinates of air hostess A as -1, 7, and coordinates of B as airline B as 4, -3. Now, upon observing carefully, we see that airline A has 2 passengers for the check-in, whereas airline B has 3 passengers for check-in. We write down this as a form of ratios as 2:3. Now with these we can find where should the airline staff keep the poster. We can find the coordinates of the point where the poster has to be placed by the section formula. The section formula is, in order to find the x coordinates, we have the formula m1 x2 plus m2 x1 divided by m1 plus m2. And in order to find the y coordinates, we have m1 y2 plus m2 y1 divided by m1 plus m2. You must be wondering what are the values m1 and m2. So, they are nothing but the ratios 2:3. 2 is the m1 and 3 is m2. Now we have the values of x1, x2 and y1 and y2 as well. -1 is x1 and 4 is x2 and 7 is y1 and -3 is y2. Upon applying this formula, we get the final answer as 1, 3. This is where the airlines have to place their poster. The cleaning department at the airport received a complaint saying that This area was littered by infants, by vomitings. Now they had to clean this triangular area. Now we just have the coordinates. We do not have the base nor the height. Then how do we find the area is what you're wondering. Right, coordinate geometry is such a beautiful subject, has a beautiful solution for this problem too. Now let us name this triangle as triangle A, B and C. Now coordinate geometry has provided a wonderful solution to find the area of triangle with these coordinates. The formula is half times, oh alright, I forgot to explain you what do these two bar lines indicate. Well, it means modulus. To be simple, suppose within these two lines, suppose you get a value as -2 and you have these two brackets, so when you remove these two lines it becomes 2, meaning the value should be positive. It should not be negative because the area of a triangle can never be negative. Right, so now moving on, we have the coordinates. Let me read out the formula for you. The area of triangle is half x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Now we have all the coordinates. X1 we have -5 as x1 and -1 as y1 and 3 as x2 and -5 as y2 and x3 as 5 and y3 as 2. Now upon substituting all these values we get half of 35 plus 9 plus 20, which is 64, which gives us 32 square units. So this area is 32 square units. Now, since we have found out the area of the region, the cleaning department can accordingly bring the buckets, the mops of various size depending upon this area. Also the quantity of phenyl or the quantity of sprays to be used. The centroid of the triangle divides the triangle in the ratio 2:1. This is divided in the ratio 2:1. The centroid is the concurrence of medians of the triangle. The centroid is denoted by the letter G, and the formula to find the centroid is x1 plus x2 plus x3 by 3, comma y for the x coordinates, and y1 plus y2 plus y3 by 3 for the y coordinates. Now, upon substituting all these values, we get the coordinates of G in our case as 1, 1.3. Now, they can easily place the Gaussian wet floorboard on the floor. Now, before they start the boarding, their hostess needs to know from where she should stand so that everyone can see her clearly and follow her for the safety demonstrations before the takeoff. So we have to find this midpoint, the coordinates of this midpoint. Now there is a formula known as the midpoint formula, which is simple, like you find the average like that only. It's quite simple, it's almost same. So this is x1, this is x2, so we have x1 plus x2 divided by 2, which is 11 plus 6 divided by 2, that is 17 divided by 2. And for the y coordinates, y1 plus y2 divided by 2, that is 6 plus 9 divided by 2. that is 15 by 2. So the coordinates are 17 by 2 comma 15 by 2. So coordinates of this point are 17 comma 2 and 15 comma 2. This is where their hostess has to stand so that she is visible to everyone and everyone can see her clearly for the safety demonstration. The ground force has to attach this stairs to the aircraft. In order to attach, they must find the slope of this staircase, and the engineering department will do some calculations with which the ground force will be able to connect the staircase to the aircraft. First, we have this angle theta as 45 degrees. Now, the engineers have to find the slope of the graph. So, the slope of this graph is tan 45. So, there are few conditions for this. Let us say this is the x-axis and this is the y-axis. Now, the slope, it says that if the angle made by x-axis in anti-clockwise direction, so yeah, we can see that this is anti-clockwise direction, is theta. This is theta. Then the slope m is equals to tan theta. Now, tan 45 is equal to 1. So, it is 1 degree. Now, the engineers will perform some more calculations, some more advanced calculations, and then they'll find out the angle at which they have to align the aircraft and the staircase. Now, in the other case, we have two cases. So let's take the first case. We are given the equation of the line. This is ax plus by plus c is equal to 0. Now we have to find the coordinate, we have to find the slope, and the simple formula for the slope is minus a by b. Here we are given the coordinates x1 comma y1 and x2 comma y2. Now let's say this is the coordinates of a and these are the coordinates of b. Now we have to find the slope of this staircase. So the formula is simple. M is equals to change in y-axis by change in x-axis, or it can simply be written as y2 minus y1 divided by x2 minus x1. This is how we can determine the slope. Let's quickly revise how we can determine the slope in 3 ways. The first way to define the slope is when the angle made by x-axis in anticlockwise direction is theta, then the slope is m equals to tan theta. And when the equation is ax plus by plus c is equals to 0, then the slope is given by minus a by b. And now when we have two coordinates, then the slope is given by change in y-axis by change in x-axis, that is y2 minus y1 divided by x2 minus x1. Before the takeoff, the pilot should check some of the conditions. So, some of the conditions for takeoff are the path of takeoff should be collinear, and the path of takeoff should be parallel to the ground. Also, the path of takeoff and the ground should be perpendicular. Now let us have the view of the cockpit. So amazing, isn't it? Yeah. Now, let's get back to the conditions. So the path should be collinear, meaning we have these 3 points. Now, collinear means they should lie on the same straight line. But now, here our way of examining or looking at the collinear points is different. In order to be the collinear points to be in a same line, the coordinates, I mean these three, let us suppose these as A, B and C. If they are collinear, AB is equals to BC, which is equals to CA. If this condition is verified, we can say that these three lines are collinear. This is how pilots determine whether the path is collinear or not. Getting back to our second condition, the path of takeoff is parallel to the ground. If the path is parallel, let's say this is the ground and this is the flight path. So I'm denoting this by the yellow color. This is the flight path. So if these two need to be parallel, we need to prove that the slopes of these two lines are equal. That is m1, that is slope of this line, is equal to m2, that is slope of this line. If these two slopes are equal, we can say that these two lines are parallel. Now, the third condition is the path of takeoff and the ground are perpendicular. So even that's quite simple. So let's say this is the path, this is the ground, and this is the path of takeoff again. Now, in order to prove that they are perpendicular, that is, they are perpendicular, we have to prove that, let's say this is a slope 1 and this is a slope 2. So upon multiplying this slope m1 into m2, we must get the answer as -1. If this condition is satisfied by these two lines, we can say that these two are perpendicular.